Today, we will be going over the basics of FFT using MatDeck's formula templates. The formula templates are snippets of code which are typically used in certain fields and allow the user to achieve an objective quickly and without the need of any code. They automatically paste the lines of code into the canvas and allow you to only change any values or add your own values to the scenario to enable you to reach the objective. To add a formula template, all you need to do is head over to the Insert tab, and then on the rightmost side you can see Select Template. To access the FFT formula templates, we need to first choose the FFT category. To do that, we need to adjust the first combo box. As you can see, there are a few options and we need to click on FFT. Now we have all the FFT formula templates. When you hover over one of the formula templates, a picture on the left hand side will appear to allow you to preview what the formula template looks like. As we can see here, we have several FFTs with the graph ready, as well as ArrayFire FFT, which allows for GPU acceleration when calculating the FFTs. To add a formula template to the document, we first need to choose which template we would like to add. In this example, I'm just going to use the FFT with graph ready. Once we click on that, all we need to do is click on the Insert button and then click on the canvas. And as you can see, the formula template has been added. Now, we can see how the formula template adds all the lines of code we need to complete the FFT. It adds the sampling frequency in Hertz, which is stored in the variable fs, and then also the input signal in the time domain, the number of frequency points for FFT, frequency axis, and then here is the actual code itself. It calculates the FFT, it graphs it, and then it plots it. And here is the plot. You can see though, however, since for our input signal we only have a vector which is filled with 2000 ones, it is not as animated. Now, as mentioned before, while the formula template does provide all the necessary lines of code needed to complete the FFT, we can modify it and change it to work for our specific scenarios. For example, instead of having a signal vector which only has 2000 ones, we can instead make it so that in each section of the signal and data, it's actually a value of sine x. And now we can see how it's already changed. We can also modify the size of the vector. Instead of 2000, we can change it to 20. And throughout all of this, we can see how MatDeck's live document instantly changes the data on the graph, as the document is updated in real time and any changes can be immediately reflected onto the graph. Now, just like we did the FFT here on a small vector of 20 or even 2000, we can do the same but with GPU acceleration. To do that, we'll need to check if we have a GPU which can be utilized by a computer, and then all we need to do is select the ArrayFire FFT with graph ready. It is nearly an identical template to this, however it utilizes the GPU to accelerate and speed up the FFT to allow you to calculate it for much larger data sets.